Hey, how are you? Today I'm gonna to show you how to read the graph of accelerated motion. So in a previous class, we have seen how to read the graph of distance time graph and the velocity time graph and what to be calculated from both graphs. So today directly I'm going to see how to read the graph of uniformly accelerated motion. To say the body is uniformly accelerating when the velocity of a body increases in a constant way. In a constant way, if the velocity increases, the body is said to be accelerating uniformly. This uniform acceleration of the motion of a body can be shown graphically so that let's see this for example, let me say this example. The car shown below, the car shown below travels with an increase with an increase increasing velocity increasing velocity. Its velocity is not uniform. As you see from the graph, the velocity is not uniform. The distance it covers in equal time is not equal, because this means the distance between dots increases. As you see, the gap between these dots and these dots are not equal. This means this types of motion is called uniformly accelerated motion. Uniformly accelerated motion. Uniformly accelerated motion. Okay, but the acceleration or increasing in the velocity is constant. Increasing in velocity is constant. However, the distance between each dots is not equal, but increasing velocity is constant. That means under uniformly accelerated motion, the velocity should be increased. The velocity should be increased. Therefore, we say the acceleration is uniform. The acceleration is uniform. Now let's see another example. Another example. Let's say, for example, example number 2. Let's say example the bus increases. The bus increases its velocity by 2 meter per second in each second, as shown in the table below. Let's say this is the table, and time and velocity is given. Time in second, velocity in meter per second. When time is 0, velocity is 0. 1, 2, 3, 4, 5. Let's say 5. The velocity will be 2. This is 4, because it says the bus increases its velocity by 2 meters per second. It means in each and every second the velocity is constant, which is 2 meters per second. Therefore, this 6, this is 8, this is 10. As you can see from the table, the velocity of the bus increases from 2 meters per second to 4 meters per second, and from 4 meters per second to 6 meters per second, and so on in each second. This is what? In each second. The increase is by what? By 2 meters per second in each second. This can be shown graphically. We can put this graphically. Now let me draw the graph for this table. For this table, what the graph looks like. The graph looks like this. This is 1, 2, 3, 4, and 5. Here is 2. It starts from 0 and the 2, 4, 6, 8, and 10. This is velocity in meter per second. This is time in second. Time in second. Now we can take any point. Any point. Let's say this is the graph. It looks like this. 1 second is 2. 2 second is 4. And for 3 second it is 6. For 4 second is 8. And for 5 second it is 10 meter per second. So let's take the point 5 and the 10. We say that the first intercept is always the value of x-axis, that is indicated. This is time. This is for time, and the second intercept or the second coordinate is velocity. Therefore, this is velocity. Velocity. This graph represents velocity time graph. Velocity time graph. For what? For uniformly accelerated motion. For uniformly accelerated motion. For uniformly accelerated motion. On the vertical axis, this is y-axis. On the vertical axis, the velocity increases from let's say from 0 to 10 meter per second. It starts from these two and the end point is 10 meter per second. Okay, this is the vertical increase. Then the horizontal increase or that represents time increases from 0 to 5 second. 0 to 5 second. So that we can remember that, let me say this, NB, remember that from velocity time graph, we can get, or you can get the acceleration. This is always true. The velocity time graph is, or the slope gives us what? The acceleration. But how? Who can tell me this? How we can get acceleration from velocity time graph? To get the acceleration from velocity time graph, we have to find the slope of the graph. If we can calculate, or if we calculate the slope of the graph, that means we are calculating the acceleration. To get the slope, you have to choose 2 points. Let's say this point, or this point, or this point, and or whatever. To get the slope, you have to choose 2 points and find the vertical increase. Let's say from 0 to 10. Therefore, the vertical increases is from 0 to 10. The horizontal increase from 0 to 5. 0 to 5. So the vertical increase means the velocity change. Vertical increase in this graph, in this case, represents the velocity change. And the horizontal increase means the time changing. Therefore, we have to use the same formula that we used in the previous class. This means slope is equals to in this case, is acceleration of what? Or let me say this, acceleration is equals to a slope of velocity time graph. That is vertical increase over horizontal increase. This is the formula to calculate the acceleration from given the given graph. Now, if you take 0, let's take 0 and 0. The first intercept is 0, and also the second intercept 0 and 0, and for 5 it is 10. I take this point means 0. When time is 0, the velocity is also 0, and when velocity is 10, time is 5. So this is time, this is velocity, 5 and 10. This means the vertical increase is from 0 to 10, and the horizontal increase is from 0 to 5. 0 to 5. So 10 minus 0 means it is 10. 10, that means vertical increase is, let me say, this is slope is equals to vertical increase from 0 to 10 over 5 to 0 is equals to 10 over 5, which is 2 meter per second. This is meter per second square. Meter per second, because from velocity time graph we say that we can calculate the acceleration, so that the acceleration of the train from the graph is equal to 2 meter per second square. Note that the distance time graph for uniformly changing velocity is a curve. So you learn this in the future, but let me write this as a note. You can say that, let me say note that distance time graph for uniformly or let me say for uniformly changing velocity is a curve. Now let's generalize this. For uniformly accelerated motion, the graphs looks like this. Let's say this is acceleration, and this is velocity, and this one is distance. For x-axis, always time in second. This is also time in second. This is time in second. Velocity in meter per second. Distance in meter. Acceleration in meter per second square. So the graphs looks like this. For uniformly accelerated motion, the acceleration time graph looks like this. For velocity, it looks like this, and for this, it is curve. However, you will learn this in the future. It is a curve. Now, let's see another example. That is, let's see this graph. From this graph, this is velocity time graph. So as an example, let me say this example, the velocity time graph below shows the motion of a car. So answer the following question by reading from the graph. As you can see from the graph, when time is 2 seconds, the velocity is 6 meters per second. For 4 seconds, it is still 6. For 6 seconds, the velocity is 10, and finally when 0 is, it is also 0. So let me write the question. From this graph, what you can calculate, or let's say A, what types of what types what types of graph is it for the car, B, what is the velocity of the car at t is equals to 2 seconds. C, from from what from what to what time does the car that the car has a constant velocity, the constant velocity. D, for yeah, from what to what time does the car accelerate or change its velocity. E, when does the car decelerate? You know that decelerate, what decelerate means? That means decrease its velocity. There are the question prepared from the graph, so that from the graph what you can read. One, what type of graph is it for the car? Let me show the graph again. Here is the graph. What graph is it for the car? The figure shows the velocity time graph for the car. Okay, as you can see from the graph, the car has different type of motion, so that the car has different types of motion. So the graph, what types of graph? The graph is different. That means sometimes its velocity increase. Look, from this it increase, and here is there is no velocity, and that means sometimes it increase and sometimes it decrease and sometimes it is constant. That is therefore from this graph one can read sometimes the car slow down, and sometimes it is speed up, and sometimes it is constant. B, from the graph, what is the velocity of the car at 2 meters per second? Let me show you. At 2 meters per second, here, 2 meters per second. The velocity of the car at 2 meters per second is what? From the graph, it is 6. See, from what to what time does the car has a constant velocity? What is the constant velocity? The car has constant velocity. Here is the constant velocity. Therefore, the car has a constant velocity from 2 seconds up to 4 seconds. From this to this point, the velocity is constant. D, from what to what time does the car accelerate, or there is change in velocity? Look, the car accelerates from 0 up to 2 seconds. It's accelerating here. And from 2 also it is accelerates from 4 seconds up to, from this second up to this second it is accelerating. Therefore here velocity is increasing. Velocity increasing. That means in this point the body is speeding up. Speeding up. And also at this point speed up. Speed up. Okay, therefore the velocity is changing or increasing from 0 up to 2 seconds and from 4 up to 6 seconds. What does the car when does the car decelerate? Decelerate means negative acceleration. Here is negative acceleration. When does there is a negative acceleration? The car decelerates from the graph. Let's see. The car decelerates from what? From 0 second up to 10 second. From 0 up to 10 second, the car is what? Decelerating. Decelerating. Now, let's summarize and some points on this chapter, and let me show you the textbook, and we will see the review question together. The review. It is the question number 1 says that. Question number 1: a bicyclist travels with an average velocity of 50 meter per second, 15 meter per kilometer per hour north for 20 meters or 20 seconds. Sorry, for 20 seconds. What is his displacement in kilometer? In kilometer. So we do have given here. Given velocity is equals to 15 kilometer per hour and time is 20 minutes. 20 minutes should be changed into hour because it says kilometer per hour. It says kilometer per hour. Therefore this is equals to 0.33 hour. 33 hour. Therefore, displacement can be calculated. S is equals to V times T. V times T. 15 times 0.33 means is about 4.99 kilometer. Question number 2. The car accelerates from rest. Initially it is 0 and finally it is 90 kilometer per hour in 10 seconds. What is its acceleration? Therefore, this should be changed into meter per second. We know that 1 meter per second is equals to 3.6 kilometer per hour. We know that. Therefore, 90 kilometer per hour should be changed into meter per second. In this case, if you are divided 90 divided by 3.6, you will get 25 meter per second. 25 meter per second. Now the acceleration is equals to final minus initial over t. Final it is 25 minus 0 over 10 means it is 2.5 meter per second square. 2.5 meter per second square. This is question number 2. Question number 3: an aircraft landing. An aircraft landing means there was an initial velocity and comes to rest means final velocity will be 0 in this case because it comes to rest. It comes to rest means final velocity is equals to 0 and the initiality is 215 kilometer per hour. Therefore, this should be changed into meter per second. Just to follow the same procedure, and this will be 59.7 meter per second. This is the initial velocity. Therefore, this aircraft is decelerating. It is decelerating. Therefore, acceleration is v minus u over t means 0 minus 59.7 meter per second over time is 2.7 second. 2.7 second. Therefore, when you this is equals to negative 59.7 over 2.7 means in this case the answer will be 22.12 meter per second square. 22 meter per second square. Second. Question number 4. Question number 4 says that a certain car has an acceleration of 2.4 meter per second square. Assume that its acceleration remain constant starting from rest. How long does the car require to reach the velocity of this? In this case, the givens are accelerations is equals to 2.4 meter per second square, and initially it is 0, and finally it is 90 kilometer per hour. 90 kilometer per hour means 25 meter per second, and we are requested to calculate the value of acceleration time. Therefore acceleration is v minus u over t, and t is equals to final minus initial over a. Now just substitute the number. This is equals to finally 25 minus 0 over 2.4. So when you calculate, or when you divide 25 by 2.4, the answer will be 10.42 second. 10.42 second. Question number 5 says that from the graph of this, from the calculate the velocity of the car. It says the velocity can be calculated by using, these are the same. You can use the same procedure using slope. Slope is equals to the vertical increase over horizontal increase. Let's say vertically, let's say from 0 to 5. 5 minus 0 is 0. 1 is 1 is equals to 5. Therefore in this case velocity is 5 meter per second for each point, for each dots. What is the distance traveled when time is 6? Let's say, let me add here 6. 25, 35 is the gap, or the velocity increased by 5. In each point the distance between point is 5 meters. This means 35. It is 35 at 6 seconds. The distance is 35. Question number 6 says that from the graph, calculate the acceleration of the motion. What is the slope of the graph equals to, and what is the velocity? This is the same. So use for A and B. Still you can use the formula of slope. Slope is vertical increase over horizontal increase. Therefore let me calculate here. Vertical increase from 0 to 10 means 10 minus 0 is 10. Time is 0 up to 1. It is 1. It is 10 meter per second square. For each point it is 10 meter per second, 10 meter per second square, 10 meter per second square. At 8, the gap between the velocity is increased by 10, which means 0 is 0, 1, 10, 2, 20, 3, 30, 4, 40, 5, 50, okay, 5 is 50, 8 is 80. It is 80 kilometer per hour, or meter per second, sorry, meter per second. Question number 8. The data for freely falling body is recorded as in a table below using the given data. It says for the time 0, velocity is 0 meter per second, for 1 9.8, and so on. So we can draw the graph, velocity time graph. It looks like this. It looks like this. This is 1, 2, 3, 4, and velocity is 0 and 9.8, and here is 19.6 and 29, okay, and so on. So you can draw the graph easily using the step mentioned. What is the relation between velocity and the acceleration? When velocity increase, there is acceleration. Therefore, acceleration is the rate of change of what? The rate of change of velocity. The rate of change of velocity. So they have a direct relationship. How does the velocity of freely falling body changes with time? How does the distance it has fallen changed how the acceleration. So the height can be calculated 1 over 2 gt square, we say that, and the acceleration is changed into a is changed into g for freely falling. It's a freely falling body. That is why the only force acted is acceleration due to gravity. And question number 10 and number 11, just try by yourself. So this is all about today's lesson, and see you next. Have a nice time. Bye.